In this video, we're going to cover factoring and the different types of methods that you could use. The first method that we're always going to look for every single time is for the greatest common factor. The greatest common factor is what numbers or letters or polynomials are common to every single term. And when I'm looking at this first polynomial, I look at this and say, okay, well, there seems to be something in common between the first two terms. I can divide a 3 into both, but I can't divide a 3 into the last. It has to be common to every single term. And the only thing that's common to all of these is x. And we're always choosing, here's a note to say we're always going to choose the lowest degree of each variable, or each polynomial for that matter. So when we're doing this then, I'm going to take an x out of every term. Well, if you're not sure what I mean about take an x out of every term, we're basically going to undo the multiplication, which of course is division. So sometimes what I do to remind myself is I say if I'm going to take an x out of every term, it's like dividing every term by x. So 9x cubed divided by x is going to be 9x squared. Basically, I'm removing one x from every term. My negative 3x squared divided by x is going to be negative 3x. Now here's what a lot of people say is like, oh, I'm done, because the x cancels out. But remember, when the x's cancel out, x divided by x isn't 0, x divided by x is 1. And then of course the negative is still there. So that's all that I can do here. Now we're going to talk about how to factor trinomials later on in this video, so we're going to wait for just a second. So I'm looking again at what is in common to these these three terms. And I'm looking and I see that it looks like 2 could factor into it, 4 could factor into it, but I'm always looking for the greatest common factor. So the greatest number that will factor into any of these is 8. And then again, I'm choosing the lowest degree. So x could be taken out of this, but I could take another x and another x. I could take 3 of them. But look, as soon as I go over the lowest degree, if I try to take 4 out of every term, then I take more than what's actually there. And I'm going to end up with x in the denominator, which is problematic. So what I'm going to do is I'm going to say there's an x cubed in common to each. So I'm taking an 8x cubed out of every one. And then what I'm left with is 2x to the 5th plus 5x to the 6th. No, excuse me, the 3rd. I started with 6 and I took 3 out. And then 24 divided by 8 is 3. And then x cubed divided by x cubed cancels out or becomes 1. And always take another look at your polynomial and say, is there any other thing that I could possibly take out? And again, we might be able to factor. I see a trinomial, so maybe that's something we can do. So go ahead and factor this one here and see if you get the right answer. Pause the video. So here's the answer to that final greatest common factor. And if you notice that I took a negative out because I liked my lead coefficient to be positive. And I just realized that that number this should have been a negative here. I apologize. Positive divided by negative is negative. That should be negative. So when I'm looking at this, though, then I'm dividing each one out, and I'm looking at my final polynomial and say, is there anything in common? And you can say, well, there's a y here and a y here, but there's not a y here. Same thing, there's an x here and an x here, but there's not an x there. So I have taken everything out, and there's no common factor to 7, 3, and 4 except 1. So what we can do now is go on to the technique of grouping. And these aren't exclusive, but these are some of the commonly used factoring techniques. And they're quick to identify because they have 4 terms. So what we're going to do is we're going to look at what's in common group by group. So these two and these two. So using the same idea as the greatest common factor, but we're only doing it 2 terms at a time. So we're going to do them in groups. So I've got, this is A is in common to both. And again, if I divide both by A, if I could sneak that in there, I've got a D plus C left over. And what's in common to these two is a C. And again, dividing them both by C, I have a D plus C left over. Now, the technique with grouping is saying, well, when we divide by an entire value, when we divide by an entire quantity, so I notice that this has a D plus C in this quantity. Oops. Should have highlighted that. That has a D plus C here and a D plus C. In the same way, when we took a common number, we took a common variable, I'm going to take that entire common polynomial out. So when I have this left over, what's left in this part of the polynomial is a, and over here is c. So what's left is a plus c. Looking at the same thing here, we've got a b common, we've got a b squared common to here. And remember, when we divide that out, it's left with b minus 1. Over here, these two have a 2 in common, so I'm left with b minus 1. And doing the same idea, there's a b minus 1 here and a b minus 1 here. They have to be in common. If one was b minus 1 and one was b plus 1, it's going to be prime. I can't factor it, or I have to look for another method. So what's left is, well, we took the b minus 1 out of each term and put it out in front, so the b squared is left, and the plus 2 is left. Sometimes when we take it out, they almost look the same, like this is going to be a squared and a minus 3, and if I'm going too fast, you can always email me to explain a little bit more. This one has a 2 in common, so this is going to be, when I divide out, I've got negative a plus 3. Now, right now, they don't match. This doesn't help me. Remember, you can only take them out if these are in common, and they're not. So when I'm looking at this, I notice, hey, wait, these are the exact opposite. So what if I didn't take a 2 out, but I took a negative 2 out? So if I divided that by negative 2 and I divided by negative 2, what happens is this doesn't become a negative a plus 3. Negative 2a divided by negative 2 is a positive a, and then 6 divided by negative 2 is a negative 3. Then all of a sudden they look the same. And then I can go back to what I did before. A minus 3 is in common, and what's left is a squared minus 2. So pause the video and try to factor these. So here's the answer to number 4. I wanted to point out that when I was looking at what was in common here, there was nothing. But if I took a 1 out or factored a 1 out, then all of a sudden it creates those binomials that are the same. If you have tried number 5, you'll notice that this doesn't have, when I factor out, there's nothing in common here, so I can take a 1 out, but it doesn't help to match. But I'll give you a hint. Sometimes if we rearrange them, whoops, not 2. Then they will look. Then this will give us something that we want. So go ahead and do 5 and 6. Go ahead and pause the video. So this last one, 5 is complete. 6 is also here, and if you'll notice that I've got this done, and what I always have to look and say, hey, is there anything else that can go into this? And what I did is I did not check to make sure that I had my greatest common factor taken out. So I'm going to show you how to do that properly, but I want to look at this one. You have to look at, once you get it into different binomials or you've factored a little bit, you have to ask yourself, did I go enough? So even though I didn't catch or I didn't do the greatest common factor like I said I should have, I can always say, well, let me take out the greatest common factor at some point. So in this one, we have a 4 and a y that's in common to everything in this particular, in this pink binomial, if you will. So I've got y squared minus 4, and then I've got y plus 3. And what would have happened is, if I would have gotten the same thing, if I would have taken the 4y out at first, so this is doing it a second time, then I would have gotten y cubed. I've taken a 4y out of the original. So I'm doing this problem all over again from scratch. So plus 3y squared minus 4y minus 12. And then I would have proceeded to factor it the same way, but now I'm looking for a smaller set of greatest common factors. So here's the rest of it. And again, if you'll notice that this answer, I don't know why I put the squared. That shouldn't have been a squared there. that that answer is the same as this answer right here. So we can get it whether you caught, the easiest thing is to do the GCF first and then see if there's anything else I can do after that. But what I didn't do is I didn't catch it, so here I had to take it out later. Now the one thing I'm going to point out is I can actually factor this some more, because this one here is actually the difference of two squares. So we're going to get to that in another video, but I just wanted to point out that even though we've done a lot of work, it's still not done yet. So always look for the greatest common factor, and then this is the grouping techniques, which we will go on in the next video.